Good afternoon. My name is Dave Emmons. I am the North American Technical Training Manager for Pentair. And today's Pentair Water Break is going to be about PFOAs and emerging contaminants and our opportunities with these things going into the future. And we're going to discuss what emerging contaminants are, what PFAS is, and some of the issues with removal of this stuff. So this is going to be background information on this NSF category of regulated contaminants for certified products for removal so that we have a basis for looking at certified products in our next water break so you know what options you have available. So with that being said, let's go ahead and get started looking at this. And if you have questions, feel free to throw them in the chat and we'll try to answer them in real time. If not, feel free to hang about at the end of it and we'll be happy to answer questions then. So you've probably noticed over the last couple years headlines from various news outlets about things like PFOAs, microplastics, and lots of other potential contaminants that may show up in your news. And we want to understand that emerging contaminants as a category is really a regulatory and political term, right? This is stuff that has finally made enough awareness in the general population that it's gathering political awareness for regulation. So this has been something that's been recently discovered for more increasing impact in our water systems and is maybe currently regulated or not regulated at a federal level. But we're starting to look at it more in depth. And this is a 5-year cycle with the EPA. They open the door for new contaminants to be added to different regulatory bodies. And then after it cascades down from there, it'll hit organizations like NSF and other testing agents or certification agencies. So we can certify products for our customers so they can trust the outcomes of purchasing them. So these are things that raise concerns for health in people. And how do we go about selling or addressing these issues without really scaring people, right? Some of these contaminants have significant health effects. That's why we want to regulate them. And this gives us, once they're regulated, a place to discover quantities of contaminants in our own drinking water supplies at municipal levels, because this stuff's going to end up being on CCRs and things in the future. So emerging doesn't always mean new. That's absolutely correct. PFOAs, for example, were begun being manufactured in the 1930s and 40s. So this is a legacy compound, a ubiquitous one in our lives. It's kind of everywhere. Very, very useful chemistry. But everything has its impact. So now we're discovering this very useful chemical family has issues, right? So what are regulated and unregulated contaminants? We have things like lead and arsenic and nitrates, disinfection byproducts, pesticides and herbicides, and even PFAS chemicals are now regulated. And we're familiar with those. But there's a lot of other things that may not be and are earning their own category, like pharmaceuticals. There's thousands of medications out there. Do we want a certification for each one for removal or just the whole category, right? Personal care products. Microplastics hasn't been regulated yet. Pesticides and herbicides that may be developed or haven't been regulated yet. Pesticides and herbicides, things designed to kill pests and plants. Probably not great to be ingesting those, right? Kind of common sense stuff. And other PFAS family compounds that are part of that family. And then we're also looking forward to the future as well with things like lithium. Lithium batteries aren't readily recyclable. So we're going to have an accumulated mass of these batteries over time. And is there going to be any effects from stuff leaching out of old batteries into groundwater and surface waters? We have to start thinking about these things. So what are we going to do about these sort of things? So we have specific claims under NSF and ANSI 401 for certain things. There's one for pharmaceuticals, there's one for personal care products, and all of these have potential issues, right? Most of our pharmaceuticals are incredibly powerful drugs at small doses. Well, essentially, the reason for that is nobody wants to swallow a pill the size of a football. So they got to be powerful drugs. And whenever we ingest medications, our body processes them and we excrete them. And those byproducts are in the water and some of that unreacted medication. Most of our pharmaceutical stuff is about what's processed through us that we're using. And then you have the cases of people disposing them down toilets and sinks and things like that. And that's how they get into the environment. And we're talking about antibiotics, pain relievers, antidepressants, hormones, and beta blockers. If you need these things, you'll want to take them. But if you don't need those, you don't want to be accidentally ingesting them. And we need to have long-term studies done on the health effects of these trace amounts. And we're starting to gather some of that information as we go on. So, and we have certain treatment avenues for these. And when it comes to pharmaceuticals, you're looking at GAC or powdered activated carbon as well, RO, ozone for destruction, and advanced oxidation methods that really aren't a residential or light commercial venue that you would do those in. And personal care products, shampoos, lotions, deodorants, cosmetics, BPA is well known, endocrine disruptors and compounds that may be used for other things that we don't wish to ingest. And, being a chemistry nerd in my college days, I used to like to read bottles of things. I read my shampoo one day and it's got a compound called minoxidil 9. Well, that compound is used to break up proteins to remove stuff from your hair. It's also a spermicide. I always found it kind of funny that I had this stuff in my shampoo because it does lots of different things. Well, that's the nature of chemistry. It doesn't do just what we want it to do. It reacts with what it can react with, and how we use it determines its outcome. So we want to make sure we clean some of this stuff up before we drink it, right? Similar removal patterns here for these products with point of view GAC and PAC, RO, and ozone that are used for destruction. Here's some of the amounts for the claims to be certified against for NSF and ANSI for these existing pharmaceuticals that are already on the list. More can be added to this and stuff will get taken away in time. Some of these are pharmaceuticals, flame retardants, pesticides and pharmaceuticals, lots of different compounds, but these are all parts per trillion amounts. So these are rather potent chemicals in small doses. Not to scare you, but just don't want to drink this stuff. Now, PFAS is the family tree of these non-stick, non-smudge waterproofing compounds. Incredibly valuable chemistries. But as you can see, we have a cascade of these effects, things designed for different purposes. And in the chemistry and chemical industry, if one compound gets regulated, all I have to do is add a different branch to the tree And now I have an unregulated compound that does similar things. So there's this back and forth between industry and regulation. And you can see some of the growth of that here as we find problems with ones at the top of the tree. We start making ones. Hopefully, they don't have those same problems. But that all takes time to learn. So, big, broad category of chemicals. And here's this chart I included just to represent some of the challenges with removing this stuff. Some of these compounds, you can see the ionic charge here on the right-hand side. They're neutral or positive or negative, and that can present treatment challenges for us depending on the method we're trying to use to remove these compounds. And this is what they sort of look like from a chemical structure. And there's an analog in the water treatment industry that we're used to treating that looks a lot like these compounds from a chemistry standpoint, and those are tannins. A tannin is an organic acid, and these nonstick compounds are organic acids, but they're fluorinated organic acids. And this compound here is a carboxylic group. It's an acid here, and this is a sulfonyl group. This is sulfuric acid. That's what's added on here. And these are the ends that allow us to stick this stuff to things. And the other ends, this is very non-reactive. So you create a coating that doesn't react with anything. Very, very useful stuff until you ingest it. Then it's not so. So understand that this is going to be treated along the same lines as we presently treat tannins, but this is toxic and tannins aren't. Tannins just make your wine taste bitter and nasty. So one of the problems we have with reduction is this chart here. We're dealing with this non-charged end of the fluorine atoms and the charged end on the attachment molecule on this. So what this does, it creates an opportunity for these materials to bond just like organics do to cation resins in our softening applications, or naturally occurring organic matter. That tag end can bond to that, or they can bond together and create a charged ball of this stuff that would be removed very easily by anion resin. Or you could have something like this, that you get two tail ends stuck together and you got a double charge. So this stuff can take on lots of forms in the water as we're trying to remove it. And you can create, this is how, in this lower left-hand corner, is how anion resin is going to remove it. But what happens if it presents itself tail end down? It's not going to get removed. So this is part of the challenge with this compound as well as tannins. So we have to kind of take this into account. We also have to realize anything we put in a tank that doesn't have a charge, like part of our resin beads, the lining of our tanks, this stuff's going to stick to. So there is challenges with removing this and disposing of it properly. So understand that's why we're coming up with the methods we do. We take this stuff into account. So when you're thinking about treating this, we need to understand the concentration of the contaminant. It's actually easier to remove a lot of stuff from water than it is small amounts. Parts per trillion is a really, really needle in the haystack sort of scenario for us. We want to make sure we test the water and understand what's there. And if you're going to do field testing for PFOAs, please understand the protocols doing that. This is really, really sophisticated sampling, and you have to make sure you have no contamination from the environment getting into your sample. And you may have competing ions for ion exchange with this if we're going to use anion exchange. Same selectivity concerns with anions as we do cations. We got to manage that situation. High levels of organics in the water from well water and those sorts of sources will cause the stuff to bind to that, and we may not be able to remove it with our method, right? So we want to make sure we understand that. Real world monthly water use, any discharge or disposal regulations in your area. This has not yet been regulated for discharge under the Clean Water Act, but it falls there. And typically, when the Safe Drinking Water Act is triggered, the Clean Water Act will follow very shortly. We're regulating this on the drinking water side first for safety, but I'm sure we'll get around to this for discharge as well. So understand commercial businesses that may have this. This may be a challenge for disposal. Sizing for the appropriately certified flow rate for the removal method. This is important. You may even want to restrict flow rate coming out of your unit to keep it within specs so your customers can keep removing this stuff properly. And then there's budget and space. Can you fit a system in? And are there tools you can manage that around? Is point of use or point of entry appropriate for the homeowner's needs or your business's needs? And maintenance plans to optimize removal and make sure we do not overrun our removal methods. Once you saturate carbon or a resin bed, you can get dumping of those compounds greater than what we started with. So when we're dealing with toxic compounds under these regulations, you really want a scheduled maintenance for removal and replacement. So key questions. Do you want a certified product or do you want to design your own? Understand if you design your own and want a certification, it's expensive. That's one of the reasons why certifications, although everyone wants them on their products, they're expensive and they do drive up cost. So understand we always try to balance that when we certify things. What are your customers' concerns? Skin absorption? Or kids drinking the water in the bath? Or is it just drinking water? That's a different process. One's going to be point of entry and one's going to be point of use, depending on how you want to do this. Can I optimize that to treat more than just PFOAs? Remember, a lot of these methods are going to bulk treat the water, not just for one thing. Chemistry does not like being refined that way. If we're going to treat raw water, so to speak, we're going to treat everything at once and how we go about that. What maintenance plan makes sense for your business or your customer? Understand if you're going to get into removing this stuff and selling this stuff, having a maintenance plan or a change out plan is critical to success for the homeowner and not creating issues long term. And testing for certification in the field is really, really challenging and expensive. These are not cheap tests. So if you design your own system, build in the cost of testing for validation for your customer into it so they understand that that's not free with the equipment. So EPA recognized technologies for removing these compounds, whether it's PFAS or pharmaceuticals or any of these things in the emerging contaminant class. You're going to have activated carbon. This is our wonder child in water treatment. It does a lot and it can be optimized for these removals. Our carbon experts behind the scenes at Pentair are creating blends that are optimized to remove these things and manage your other stuff in the water as well. Cartridges, loose media systems, powdered GAC is better than granular activated carbon in this regard because we have so much more surface area. But powdered activated carbon doesn't work in a tank. It's too soft. So understand where to use these products appropriately. Anti-exchange can be in single use cartridges and they are single use and you can dispose of them. Do that. You can do it in loose media systems, but understand that's going to be an exchange tank process because the regeneration methods for these compounds with these resins is rather aggressive and you probably wouldn't even want to do them in an industrial setting unless you had to. And then there's high pressure membrane systems or RO systems. Reverse osmosis and nanofiltration will remove many of these. But one of the problems with these chemistries is they will break down over time. Just they get smaller and more difficult to remove. So RO helps address that issue when you're finding breakdown products in nature, not just the starting parent compound. And nanofiltration's got to match that entire spectrum as well. So understand what you're treating, understand the systems, you'll understand why we have the certifications and things we do. as we talk next week. Now, reasons for using ion exchange. The application of ion exchange has received considerable attention because of its effectiveness, ease of operation, and large available capacity, small footprint. And the regenerative capabilities in this is negligible for our industry at this point in time. But yes, it's very simple to use these products, but pre-treatment will be required. Follow your resin OEM's recommendations for their products. So now that we've reduced this stuff, presently these regulations are focused on potable water. You don't necessarily have to worry about discharge of RO yet down the sanitary sewer because residences are typically grandfathered. That may change in the future. Who knows? What is the municipality responsible for delivering? So this is where you're going to want to validate. If you're in a municipality and you're getting PFAS in your home, what's the municipality responsible for delivering, and can they afford to treat it? That's going to be a major challenge. That's why we can help folks out now before those infrastructure problems get started or programs get kicked off to modify municipal water. It's going to take a long time to get there. Discharge regulations, not yet on residences, but there will be there on businesses. Seek local guidance from your local regulatory agencies and states. Why states can be more strict than the federal government. Make sure you dot your I's and cross your T's on that. Single-use medias require collection and appropriate destruction. As a business, as soon as you take something from a customer's home and place it on the bumper of your truck, it is now yours, and you are a commercial entity, and you must follow that disposal process. That was from my EPA attorney because I read those issues a long time ago. If it's cartridges left with the homeowner, they can put it in the garbage. That may change in the future, but homeowners are grandfathered. If you're worried about that, to be honest, our landfills are already filled with this stuff, and it's actually the appropriate place to put this stuff because we've already had 60 years of this material in those landfills. So point source collection's far better than scattering it all throughout the environment again. So these destructive methods are out there. If you're collecting this stuff and bringing it back to your shop, realize that you need to charge for this destruction process, or you may have some liability exposure here. So understand the concentration you have in the water, competing ions, levels of organics, and flow rate that you need for this. Chlorine and PFAS reduction together at point of entry with activated carbon, and optimize point of use for drinking water like PFOAs and lead. So carbon has the same issues as anion resins do. Consult your friendly carbon OEM for guidance or use a certified product. Water chemistry is critical. Always provide a full water analysis to your OEM if you're going to ask them for help. They're going to ask for it. PFOA speciation is required, so if you're going to send in the sample, make sure you get the proper test kit and sampling devices to do so. And what exact compounds are you dealing with? It's important. And then reclamation, regeneration, and disposal issues. Make sure you manage this issue before you start addressing these compounds. So why do Pentair certify for health claims? It's because we want to make sure you have a marketable tool that your customer can believe that it is doing the job with third-party certifications. Trust me is never a great way to sell. It's also never a great way to buy. When we do our testing, we want to make sure our product outperforms and does what it says for the entire life of that cartridge when we install it. Some of our competitors do not build their products that way. That's why the devil is always in the details with certifications and testing. If it's only based on internal testing, I would steer clear of those products. And now, if it's based on NSF certification or WQA Golden Seal, that is something you can trust with that product. Why? Internal testing is kind of marketing data unless it's strictly used by the engineers.